to do the recording. Then today what we first going to do is quickly doing some quick review about plotting. Okay. So plotting over here, we are going to start to discuss is about the matplot library. So it's quite helpful. You can do a lot of drawing, plotting, okay, and over here focus on plotting. So let's take a look. So here we have NumPy, we know that. So in order to use matplotlib, generally speaking, you need to import pyplot, okay? And normally we do the import pyplot as PLT. And after you import the module, then you can go ahead start to plot. And we know whenever you want to do plotting, you need X and Y that we plot in a coordinate system, generally speaking. So in this case, over here, we generate the x-axis value using NumPy's line space, okay, generate some numbers. And then the y value is sine and cosine. The sine and cosine values, okay, just directly apply sine, cosine. And then you can see it's quite simple over here. Whenever you want to draw some curve, then you just call plt.plot and plug in with the corresponding x and y values. And then also call the plt.show, okay, to let whatever the plotting be displayable. So this is the simplest cases. Next one, let's take a look, is you can also plan some space, plotting space, okay? We call it a figure. So over here is you first create some empty plotting window. So you call plt.figure. And then on the figure, you can add, we call it a subplot, okay? In this case, if you take a look at the output, we have 3 subplot. Is it grouped together? Is it in one presentation? Is it, so over here, you can call the add subplot. And then you specify, because this is 2 by 2, kind of, you want 2 row and 2 column of subplot. And what over here, the third parameter, just specify it's going to be the first plot or second plot or third plot, is it? And then you assign the plot, subplot, to some variable. So over here, you call add subplot is just to create the plot. You haven't started plotting yet, is it? And then over here, you call plot.plot, is a plt.plot. And you didn't specify it's going to be plot on which one. Then by default, it will take the latest one. Okay, the latest one is AX3. So this plt.plot, it will be plotted on the latest one, AX3. What it's going to plot is just some random numbers, does the com sum, is it? And here is specify the formatting of your plot. It's a dashed line. And the K represents black, okay? So it's black color with dash line. So that's what this last, this bottom right corner shows the figure, is it? So it's the random number does the com sum and showing as dashed line and the black color, okay? And then what next you try to show is, you try to do AX1. So AX1 is the first one, is it? Over here, you're going to generate what? This is just not a plot your XY value. For this one, you're going to do histogram. Is it generate the bar shape? And so this is called histogram. Okay, with this histogram, those are the numbers you're going to generate some random number, 100 random number generated. But for this histogram, you're going to have 20 bins. So basically it's 20 buckets, is it? And the color is black for you to do plotting. And this alpha is just some transparency, okay? Over here, you can see it's very dark, is it? And if you put like as to 0.3, then the color is going to be very light, so kind of transparent, okay? So this shows you can also do the histogram. And the last one, you want to draw on the second one. This over here it says scatter. The scatter is just no curve, is not to connect, just exactly the point, is it? So the x value, the y value, is it where it is, and this is called scattered plotting. Okay, that's the next one shows you can specify more as a subplot, like what we just. So over here you have 2 row and 3 column of subplots, is it? And what the next one shows is you also create a subplot. It's 2 by 2, is it? But this time you want both the x and the y shared, is it? So that's why you have shared 2, shared y also 2. Okay, and also over here we can see whenever you do the plotting, you just plot what? Histogram, is it? So those buckets, the histograms, do the counting. And over here, if you take a look, the color is still black. But if you take the alpha value this time, we change, is it? It's 0.3. So it's more transparent, is it? So that's what the alpha value means. And over here, you can also adjust the space. You can also adjust space. So here you don't want horizontal, vertical has any space between the plots, is it? So that's why you just set them to 0, okay? So when you have multiple plots, you want to group them together, then you can take this strategy. Okay, then the next one, that's just some random number that drawing. But this time, if you take a look at the color, then this time it's green color. Is it? Because a lot of time you want different color. And also you can specify the style, line style. This is dashed line, is it? And you can also specify the specific point, what it's going to look like. In this case, it's dot, as it is dot. Yeah, so you can see there are a lot of options for you. And what the next one shows is still some random data is generated, and then you're going to do the plotting. Over here, color and the line style, is it? This time, if you take a look, we also add something, we call it label, is it? Okay, for this style, you call it label. For the second plot, so over here, we have 2 group of lines. One is dash, one is a step. Is it? The second is a step. And the label is called step post, is it? So you can also have your line be labeled. So kind of you give each curve a name, is it? And why that is helpful is then you can do the legend. Okay, so if your plot has a label, then you can use the label to create a legend. And here, where do you want to put your legend? If you specify the best, then the plotting itself will find the best place to put. In this case, it's top left corner. If over here it's spacious, then it may be put here. So the plotting itself will pick the best place, okay, for you. You can also specify, of course. Okay, what the next part shows is we can also, we learned the label and the legend. The next, it's called ticker. Okay, so what is a ticker? So over here, if we take a look, okay, we specify the plotting window and we add a subplot. This time we just have a single subplot, is it? And then what you're going to plot is some random numbers come sum, is it? So those are pretty straightforward. And over here, you see, you define your plotting's x ticks, is it? And also your x-axis, you also give them some label, tick label, is it? So the tick is just like over here. So you don't want every single value be displayed. You just want to at a certain space. you have some value be labeled kind of over there. So you call that a tick, okay? And over here, for each tick, you don't want it to be directly displayed with the value. You want it to be displayed as some label. Then in this case, you can specify, okay, the x-axis is the tick's label. And over here, if you take another look, you will find those label display also has some tilted, it has some angle. So you can specify the rotation. Over here, it says rotate as 30 degrees, is it? And you can also specify the font size for your tick. In this case, it's a small size, okay. And then next you can, so for your plot, you can assign those properties to your plotting, etc. So over here, you can use this dictionary, okay? And with this dictionary, then you just call the plotting set function and then assign this dictionary to it. Then it will assign all the features you just specify. Otherwise, you can specifically call set title, set x label, okay? Over here, oh, and the other thing is the title, etc. For your plot, then you can have the title also be displayed on your figure. So this is just for your report generation, because for machine learning data analysis, one of the important part after your research is you give visualized visualization report, etc. So in this case, then plotting can play very important role. And what is the next part going to show if you take a look at this case, is it? So we have this plotting window, and then we have the subplot. And then over here, we have 3 curves be plotted, is it? It all does the com sum. But over here, it just shows different line formatting, as well as just dark color, is it? And the second one is a dashed line. The third one is what? Is just a dot. Is it? So you can specify the curve type. Is it? And then you label. Then did you see? You just have said, okay, my legend, where it's going to be best. In this case, it's not the top left corner. It's the right top corner. Is it? That's why. That's because you put best. It will find the best balanced place for your graph. Okay, and then the next one, let's take a look. You see this diagram. That's kind of fancy, is it? It's not just the curve itself. It also has something on your curve. Is it something we call it annotation in this case? So you can also manually add some annotation on your graph. So how do we do that? Is it? So in this time, our data, you got your data from some CSV file. You can also do that, okay, read some CSV file data, okay? And then you specify which column you want to do the plotting, is it? And then you can start your plotting, specify, in this case, you call the plot function, is it? Then you specify where you're going to do the plot, okay? On that subplot you created, okay? And the style of the line and the color, you specify of them. And then what over here is, oh, I have some specific data I want to emphasize those specific points, is it, on my data. So over here, what you can do is from your data frame, you can pick out those data, is it? And then also give them some name, is it, over here? That's what it does. And then for those, you can add annotation. So that's how we add those those critical point, is it? Add some annotation here. And how do we add annotate? You just call the annotate function, okay? And as usual, you need to specify where you're going to annotate. So over here, you specify where you're going to annotate. This SP, X is a real data, is it? Is a real data on the curve. Okay, That's a SPX data based on the definition, is it, as of the date. So you can find the specific point, is it? But your annotation, this is your annotation. This word is your annotation. The arrow is your annotation, the word. The arrow and the word, those are your annotation, is it? So where are you going to start your annotation? Is the XY value, is it? You need to specify. So over here you said, okay, I'm going to start as what? The date. X value is the date. Is it? You specify the date. And the Y value is from what? Is from your, this is your SPX, that data frames data, Y value. But you're not going to draw directly here, is it? So you're going to have the offset. So this part is the offset. So over here, it's the offset. My touch pen not working well. But over here, it's the offset. So this part, 75. That's the offset. Okay, so you said, okay, I'm starting here. Is it? The Y value is starting here. Your original data value is on the curve, but you're going to start drawing your arrow here. Is it? That's the XY. And then you specify XY text. XY text is this. Because you need to specify where on your graph you're going to add the annotation. Is it? So the X value is still the date. Is it? And the Y value is from this point, is it? You're going to add the offset to 25. Okay, so that's how you come up with where you're going to add your annotation. And then you're going to specify your annotation, what it looks like. Is it? So in this case, you say, oh, I want some arrow shape. Is it arrow shape? And you specify the color, the arrow head face, arrow width, arrow length of those. Is it? And for the word, for the output, where you are going to do your align. Is it left align and the top alignment? Is it? So that's the annotation part. And after that, you can also set X limitation, Y limit, because your whole data frame is quite large. Is that you can just pick a certain part of the data from your original data frame. Then you can, and you can also add a title. Is it? So you see this graph itself is quite comprehensive. Is it? Visualization report is also very well. Okay, that's the first example. And then next, let's see the second one. I need to bring up the second one. Okay, here. Okay, the second plotting note. So over here, this one we already learned. This is just some, so over here, what's the concept here is, this is the data frame, is the pandas data frame we created. You also specify the index and the column, is it? And then you can, so over here, over here we didn't import that one to do the draw. Is that you just directly call pandas data frame plotting. So you can, pandas data frame also has a function called plot. You can also directly call plot over there. And then next, let's see. The next part we already, previously we already learned is that that's one of the major plotting library you can use, the PyPlot from Matplotlib library. Is it? Over here it says, oh, I'm going to have two subplot. That's two. Okay, and it's one column, a single column, okay? And then you have some data series created. This time what I'm going to plot, you see, it's, so this part is your data frame, is it? For your data frame, you can also have the bar generated. So the first bar is just the histogram. Is it? You can also call the histogram, but in pandas you call it a bar. And then you can let it draw. And you can also horizontal. So bar H gives you horizontal histogram. Okay, the bar. So this is regarding the draw. And the next one over here, what it shows is for bar, draw horizontal bar. If you take a look here, this time we don't have, because in last time if you draw with the bar, then each different color needed to be on a single column, is it? But this time you set the stacked option as true. If you do this, then you can see the different category, is it? They stack one on the other. Generally speaking, normal case is you're going to have this, you're going to have the vertical, something like this, different color. Is it like red color, green color, yellow color, and blue color? Is it general? But if you have the stacked, then it's going to on top of one another versus parallel lined together. Okay, so that's just to show you can choose different way to do it. And what the next part shows is here is a function called cross-tab function. Okay, and the cross-tab is create a cross-tabulation table, and it's quite useful is to show the frequency with a certain group of data. Okay, so this is regarding frequency. So anyway, here we get some data frame from some CSV file. Okay, then we create a cross-tab. Okay, the table data with regarding day and size. Okay, and then here is the result. Okay, and the original data you will see it's not look like this. Okay, it's some other kind of data. So over here, the data generated of this are the frequency. And this frequency is generated with what? With the cross-tab function. Okay, so that's regarding this part. And then what we are going to do is, if you take a look at the whole data, you will find some parts not quite useful. Is it like over here, we have like 6, is it? The data, is it? So you have quite a number of zeros. So we are not interested in that, is it? So over here it says, okay, for the next part, I'm just going to collect 2 people group, 3 people group, 4 people, 5 people group. Okay, so this represent different groups and group size. Is it based on the group size and on each different day? Is it on each different day? And what over here then should compare with the previous one is here it shows percentage. Is it? That's because we did some conversion. Okay, we wanted to find the percentage of the people's size on certain day. Okay, so that's not a major thing. And then you see you can also do what? Do the bar drawing. Is it? So here the bar drawing, you just based on the data frame, you call plot and then bar. Is it? And with this bar draw, it shows what? It shows, but for each day you have different size. Is it? That's why you see under each day you have different color of bar. Is it? So it's it also gives you the grouping information in this case. Is it? Yeah, so that's the bar plotting. And what is the next one going to show us over here? We have another library for plotting you can use. It's called CBOM. Okay, also quite useful. Okay, for visualization. And for CBOM, then you can import it as some abbreviation. Okay, so nothing new over there. And over here, what we are going to do, the plotting is we do some calculation with the data that we just presented, okay, regarding the tips, is it? And based on different day. So that's regarding day, is it? And then group size is a horizontal, is a column, the group size. Those data, and then based on what is provided, we also can find the tip percentage, okay? So what we are going to do, the plotting here is to also do what? Also do bar plotting, is it? So you can also, so CBON also provide you to draw the bar, is it? Draw the bar. And the x-axis in this time, it's the tip percentage. Y is regarding the day, okay, regarding day. And the data is based on whatever our data frame, is it provided. And here it also shows the options you wanted to vertical demonstrated or horizontal. So this is horizontal presented. And this is the bar, is it? But if you take a look, you will find CBON's bar looks weird, is it? It also has this little black tail kind of thing, is it? Little black tail. And also over here it explains for CBON. And it says for each day, is it? For each day, is it? There are multiple options. Not option. There are multiple observations for each value in the day, is it? So what over here the bar does is not just that value, the value from the tip percentage, is it? What it does, it's average the value of the tip percentage. Okay, so be careful over here. For this CBON bar plotting, it also does the average calculation if you have multiple observations, okay? And then what is the bar represent this black tail line, is it? And this shows the 95 confidential confidence interval. Okay, so just extend the confidence interval. So that's regarding CBON drawing. And what is the next one just shows you can also do histogram drawing, is it? So here it also shows based on different frequency of data, is it? And you can also plot density, is it, versus the histogram. And over here, it says CBON can make a histogram and the density plot even easier, okay? In the plot function is called distribute plot. So over here, it shows us, okay? So this is CBON's, okay, distribution plot. So over here, we have two set of data. The first set of data, the mean is around 0 and the standard deviation is 1. The second one, the mean is 10, standard deviation is 2. That's why it's more flat, okay? And then we are going to do in CBON's distribution plot, is it, with both of the values, is it? Over here, you combine both of the values. And if you take a look, you will see in this single diagram, you have histogram, is it, data, and you also have what? Density distribution, is it? You have two kinds in one single plot, is it? So this is called distribution plot. It gives you better idea, is it? Yeah. So over here, this is more flat, more fat. This is skinnier, is it? That's because the standard deviation you defined, okay? Okay, so this is regarding CBON drawing. And what the next one shows is, here we have another CSV file we read in. This is about some economics data. It's about a CPI, unemployment, some other economics data. And what over here it's going to do in CBON, you can also do the linear regression line. So CBON can, so if you provide the data and if you want to find linear regression line, CBON can also help you do that, okay? So over here, you want to do the linear regression regarding M1 and unemployment. So based on those two columns, okay, I wanted to do the linear regression, and then you provide the data. So that's what over here it shows. And then next, let's see. So yeah, if you take a look, you will see, is it to give you the linear regression line? Is it those are the original data? Is it? And over here, it's just the interval, confidence interval. Okay. Okay, so this is regarding the more about plotting. And what next shows us is about, it says visualization, the distribution of data set. Okay, so over here we are going to see another, it's called pair plot function. It's also very helpful. And what over here, the pair plotting support is that can place histogram density distribution for each variable. And a lot of time you have multiple features, is it? And you want to find the kind of the relationship among the multiple features, is it? How do we do that? Over here, it shows us an example, okay? So it's still regarding that economics data. The economics, we have CPI, we have M1, we have the T-biler rate, and the unemployment rate, is it? So you have 4 features, is it? So even from this glimpse, you can see, is it, to give you, so in one plot, you have multiple features demonstrated. And over here, if you take a look, okay, for each of this plot, the column, so it has number of rows and number of columns graph generated, is it? So for each column, it's regarding certain feature, okay? And for each row, it's also regarding certain feature, is it? Then in this case, so this diagram, it describes the relationship of what? CPI versus unemployment, is it? For this one, then it describes the relationship among M1 and the unemployment. And for the last one, it just describes the distribution about the unemployment. So all of the diagonal ones, what it shows is just the distribution, is it? And all of the others, then you can kind of see the relationship among them, okay, different. So that's what this kind of plotting, and we call it a pair plot. So this is a pair plot, okay. So it's quite useful if you wanted to find the relationship, okay, the relationship. And over here it has some parameters. So this is whatever the data frame you want to plug in, is it? And over here it says, okay, the diagonal kind, what kind of relationship you want to use, distribution, is it? Over here it says, okay, KDE. What is KDE? It's a kernel density distribution. So you can pick, is it? So diagonal, it says there are some choice. You can do, although you can do a histogram, you can also do a kernel density distribution, okay? And those just specify the plotting, some plotting parameters. In this case, this is regarding that alpha channel, okay? So alpha channel. That, and we can see it's not that dark color, it's kind of a light, is it? So so over here just shows a lot of time if you want to have multiple features and wanted to show the relationship, then you can pick this kind of called pair plotting, okay? And what the next one shows is another function. It's called a factor plot. Okay, factor plot. And the factor plot, what here is that you can group data with multiple plots. Okay, group them together. Okay, so it's still regarding of tips data, is it? And over here it's regarding tip percentage. Okay, tip percentage. And we are going to pick all of those, filter out the data. Okay, so that's your data come from. And then you specify X and Y axis, is it? And here you also specify the hue, okay? So what hue here says, then CBOM will also want to color the data for the time. Because over here, when we consider the restaurant, we have time, lunch or dinner difference, is it? So you want to show it different between dinner and lunch time, is it? For the grouping information, then you can specify, okay, how you want to group, is it? So here it says, okay, group by the time, is it lunch or dinner? And the column, so what is the column, is it? So over here it's specified, because the factor plot will not just generate a single output plot, it will have multiple plot, okay? Multiple subplot, then for each sub of it, how you differentiate, is it? So over here it says, okay, it will have column of graph and based on smoker, based on this grouping information, okay? And you also specify what type of your graph you want. And over here it says, I want to display as bar, is it? Okay, and then the result shows like this, is it? So over here, so this is smoker. This smoker is based on the definition of our column, is it? But this is not your data frame. This is regarding your subplots column. So we have two columns of plot, is it? And also we specify the hue as time. That's why differentiate your dinner as blue and lunch as orange, is it? And then based on certain dates, is it? And give you the clear picture of the relationship. And what the next one shows us more, is it? And over here, it's still about factor plotting. And this factor plotting, this time you also specify row, not just column by smoker, is it? So row is time. Okay, so what does that mean? That means if you take a look, the result you will find this time, I have two rows of plot. I also have two columns of plot, is it? And then if you take the first row, both of these are regarding dinner, is it? And the second row is regarding lunch, is it? And the column, the first column is all about non-smoking. And the second column is all about smoker, is it? So over here, it just shows you can do some further detailed grouping information visualization report, okay? Okay, and the last one for the factor plot, what it shows is you can also pick it. Here it says the kind is box. Okay, so what is this, the box? So over here, the box plot, it says box plot gives you some idea about the media. Okay, so media, if we take a look at our output of our, so this is just regarding tip percentage versus day, okay? And we don't have multiple column or row, is it just a single subplot? And but over here, the kind is a specified box, okay? So what the box is shows, so you over here you have the box, that's it. And within the box you will find this vertical line, is it? So basically that vertical line just shows the media value, okay? And then you also have this two vertical black line outside of the box. That will just tell you 25 and 75 percentage, the percentile, the quantile, okay? And what is over here, it just shows some minimum and maximum, okay? And this is just, I'm sorry, I got messed up. Over here, let me re-clear it. So this is the media, okay, 50%. So the box, totally, the left one is take the 25%, and the right one take the 75%. Okay, and then this is the minimum. And this vertical line is the maximum. of your data. And you may also have some, so those are considered as outliers. Okay, so that's what this box style reflected. So it's a kind of also give you some idea about a certain percentile and minimum and maximum of the data. Okay, so that's regarding plotting. And what next we are going to do today is also some other new concept. Another learning. So last class we learned the model selection and the parameter tuning. This time let's take another concept. It's called ensemble learning. The concept itself is not too complicated. Ensemble, the meaning is you have multiple things together, is it? So what over here is says the concept is you can combine different models together to create ensemble learning. Okay. One of the case probably we already kind of used is random forest. Is a random forest, it's you build multiple trees, is it? And then you group them together, is it? So that's kind of. So ensemble learning is you have multiple models together, okay? And if when we build multiple models, and then but how do we pick the value? Is it? And why do we need ensemble? It's because the error. Is it? Last class we discussed bias and variance. Is it? And a lot of time you also have noise of your data. Is it? So if you use ensemble, then you can minimize the impacts of those factors. And so ensemble is we can create a set of classifiers. Okay, you can classify not just a single one, set of classifiers. And then you combine them together, okay, and to achieve a better prediction. Is it? And when you, because you have a set, not a single one, when you do the predict, how do you predict? Different one give different accuracy, is it? So then in that case, you based on majority voting. Okay, if among the 5 models, 3 models predict it's class 1, then you just say, okay, it's class 1, because the other 2 said class 0, but they're minority. So you use majority voting concept. And generally speaking, over here, when we discuss ensemble learning, we have 2 ways. One is called bagging, the other is called boosting. Okay, and the bagging, what it says is to reduce overfitting. Okay, and how does it reduce overfitting? It's going to use some random combination of data, but with repetition. Okay, so that's how it achieves the overfitting. And what boosting going to do is, it's going to build powerful models, but from weak learners. Okay, and the weak learners, how do you improve? Is it? It's from their mistakes. So we are going to see the concept about that. Okay, and the ensemble techniques, so when you group them, how you group them, is it? So there are multiple, one is called mode. Okay, mode is just based on most frequency, so based on the frequency. The second, average of the result. Okay, the third, you can weight it the average. So it just shows multiple ways. Okay, then the next is called bagging, is it? So bagging is abbreviation, it's called bootstrap aggregating. Okay, that's the concept. So the idea is you have observations, is it? And then you try to build your training set. Okay, your training set, you're going to randomly collect some data, but with replacement, and then apply different models to train, is it? And then you're going to aggregate them together. So that's a concept called bagging. Okay, and the boosting. Boosting, then the concept is you have the whole data set, you train your model, is it? And you test, and you find there are some errors, is it? And with these errors, you're going to add weight to those error data. Okay, and then you're going to retrain and retesting. Okay, so you keep like this and make your model more strong. So that's the concept of boosting. That's why we call it boosting, okay? Okay, and then next, let's see. Learning with the ensembles, is it? So basic idea we already see is it's just a training set, and then you do some way of the classification model, and then you do prediction based on majority voting, and you pick the predicted result. Okay. Okay, the first one is bagging, is it? So this is bootstrap aggregation. Okay, that's how the word comes from. So bag. So it's bootstrap part, aggregating part. Okay. So the idea of this is you have your training set, is it? And from your training set, you pick your data to do the training. But this data, it's with replacement, okay, with replace, and then you apply different models to train, okay, and then do the majority voting. Okay, then let's see, what's the concept about samples with replacement? Is it the sample with replacement? So like over here it shows. So here we have the sample index, 1, 2, 3, 4, 5 to 7, is it? And the bagging round 1. Okay, bagging round 1, if you take a look, you have multiple 2 appeared, is it? So this is called, you still have 7 samples, is it? But among the sample, you have some replacement, is it? So the next round, the same thing, you have some replacement. Okay, so this concept is called bagging, okay, with replacement. And then next, let's see the boosting, how the boosting works. So the boosting is from the original training set, is that you draw a random subset of your training. But be careful, this time is without replacement, okay? And then you have the weak learner, C1, is it? And with this, of course, you have some error, is it? Then you are going to add 50% of the same errors. So those 50% from whatever previously misclassified. Okay, and then you're going to add this 50% to the second subset of the data to do the second model training. Okay, and then for the third one, then you're going to also pick data based on the first 2 that don't disagree with each other. Then you're going, so the focus here is because you keep train those data that already report error, is it? And of course, you're going to stronger your training, is it? So this concept we call, that's why we call it boosting, is it? And one of the one that used a lot is called ADA boosting, is it? So that's a concept about boosting. Okay, so we already know the concept, and what next is just take a look the example. Okay, let me see. Okay, this example over here. Oh, I cannot. I need to stop sharing. Bring that this one out. Okay, so let's next take a look of example about how bagging and boosting works. Okay. So this time our data is from the UCI machine learning repository. Okay, it's some letter recognition problem. Okay, and what over here we try to predict this 4 picked out letter ABPR. Okay, and over here we import logistic regression. Okay, last class we also learned the confusion matrix. Is it? And the decision tree, we learned SVM, we also learned. Here we also have voting classify, model selection. And today we also learn bagging, etc. So of those, let's take a look. Okay, so this is original data frame, etc. So it has quite a number of data, 20,000 of data sets is with 17 columns, okay? And what over here, we're not going to train all of the letter. We are going to concentrate only on 4 letters, okay? A, B, P, R, okay? And here's a glimpse of the data. And then we are going to have our data be generated, numeric data generated, is it? And we are going to pick the Y value from the letter and the X value, is it, from what we specified the X values. And then we are going to do split, is it? The first time over here, we just going to do logistic regression, is it? So it's used for classification. And we fit and we do the predict, is it? And here it also gave us a confusion matrix, is it? And also the classification report, is it? Based on the confusion matrix, we can see, and also over here, is it? The general, the precision recall and F1 score, we can see the result is pretty good. It's over 90%, is it, accuracy? Okay, then let's see, how do we do the bagging? Is it over here? Last time we learned, last class we learned the model selection k-fold. Is it? And the k-fold, you have 10 splits of the fold. Is it? And over here we did the bagging classification. Is it? And for the bagging, sometimes you also need to specify what's your base estimator. Is it? Over here, we said, okay, we want to use decision tree as our base estimator. But we are going, because it's combined, is it? It's ensemble learning. So over here, you not just use a single decision tree, is it? So over here, you're going to have 100 trees, is it? To do your model training. And then after that, we are going to do cross-validation. This over here, you call the cross-validation score, okay? And you apply with this k-fold, okay? And with the model is our bagging, is it? And then you can see the result is pretty nice. It's 97%, okay? So this shows the bagging. And previously, we also learned the random forest. Is it random forest? And you can do some comparison. Is it with random forest? Then in this case, it's 98%. It's even better, okay, than us. Okay, that decision tree. And then you use bagging. Then what next shows is a boosting. Is the adder boosting. Okay, with this adder boosting over here, what we did is we also have our model, is it? Then we do the adder boosting, and the number of estimate, we are going to do 30%, is it? And this time with adder boosting, you can see the result compare with our bagging and random forest, not that impressive, is it? Yeah, and there is also another quite useful learner. It's called gradient boosting classify, okay? And the gradient, stochastic gradient boosting, okay? It's also a quite useful tool, okay? And over here, this is boosting, this belongs to boosting. The previous is adder boosting, okay? This is gradient boosting, okay? And over here, we still do the model select k-fold. We are also going to do cross-validation from what we discussed last class. But this time, your ensemble learning, what you pick is gradient boost, is it? And you're going to do the ensemble with 100, is it? And this time, you can see the result is also quite impressive, is it? Can achieve over 98% accuracy. So the above shows us the bagging and boosting, is it? What next is to see. This is also we do voting classifier. Okay, you can also have multiple different type of learning algorithm, put them together, is it? Over here we have a dictionary, okay? Then you have the first learning is logistic, is it? The second learning algorithm is decision tree, okay? The third one, you have support vector machine. And then if you want to group them together, you can call the voting classify, Okay, with voting classify, then you can do the cross validation, is it? And then we can also do the accuracy. The accuracy, you can see it's also pretty nice. Can go up to 98%. Okay, so that's the major information today. Okay, so we learned the ensemble, a new learning approach. So the ensemble way. So it's majorly focused on bagging and boosting. Okay, and then let's see.